So we start with chapter 1 today, real numbers. Some of the things that are discussed in this chapter you have already done in the previous classes, and some of them will be new. So chapter 1, real numbers, is the first chapter that we are going to discuss today. And the first exercise is actually based on the Euclid's division lemma or the Euclid's division algorithm. And this is being deleted for the year 2021 board exam. So this part is reduced. And so I will not be discussing this 1.1 because it's cancelled from this year's syllabus. Due to COVID conditions, they have deleted 30% of the syllabus. So we have to do the remaining 70%, and we are going to take these revision classes from the examination point of view only. And the NCERT is going to be covered in 70 days. So we directly move on to exercise 1.2. So 1.2, the first question is a very simple question. Express each number as a product of its prime factors. So you've done the prime factorization method. It's nothing different. So what you need to do in this is that you have to find out the factors of the numbers given. So for example, the first question, find out the factors of 140. So you have done the factors by the prime factorization method. Okay, we start with only prime numbers. Which are prime numbers? Numbers which are divisible only by itself and 1. So it has only 2 factors. So 2, 3, 5, 7, all these are prime numbers. So do not take numbers which are not prime. So we are starting with the smallest prime number 2. The 1 is neither prime nor composite. So don't take 1, please. So 2 goes 70 times. Again, repeat with 2, 2 goes 35 times. Then with 5, 5 goes 7 times, 7 goes once. So what am I going to do? 140 is the product of 2 into 2, 5 into 7. So this is going to be 2 square into 5 into 7. So this is how we find out the factors. So this is a pretty easy question. You will be able to do all these parts. 140 we are writing as 2 square into 5 into 7. Same procedure with 156. You can do that. 156 again, start with 2. And then 2, then 3 and 13. So you're getting 2 2's. So that will be 2 square into 3 into 30. They have done by the factor 3 method. You can do by the method which I have explained, which you have been traditionally doing, I think, in the lower classes. The same process can be applied. Same process for 3825, 5005 and 7429 can be applied, and you can easily find out the factors of this. So this is nothing new. You have learned this in the previous class. Okay, and you will be able to find out the factors. So moving on to question number 2 now. Find the LCM and HCF of the following pairs and verify that LCM into HCF is the product of 2 given numbers. So what we need to do is that 2 numbers are given. We have to find the HCF and LCM of this. So how are we going to find the LCM and LCM? Let me explain this. Question number 2. Find out the LCM and HCF of the numbers 26 and 91. So 26 is 2 into 13, and what is 91? 7 into 13. Okay, these are prime factorization. Again, if you don't know how to do it, you have to do by the traditional method like this. 91, same way, 7 goes 13 times. Okay, so I've got the factors here. Now, what is HCF? HCF is what is common in the 2. So what is common here? 13 is common as a factor in 26 as well as 91. So that becomes my HCF. So HCF is 13. And what is LCM? LCM is the product of all the numbers without repetition. No number should repeat. So it is the product of all numbers 2, 13, 7. I will not repeat. Okay. So 13, I will not write again 13. So LCM is the product of all numbers without repetition. So 2 into 13 into 7. So that's going to be 26 multiplied by 7. 7 is 42. To go 140, that is going to be 182. Okay, you will multiply this and you are going to get the HCF as 13 as discussed and LCM as 182. Now comes the next part. You have to verify this. Verification formula, very important. HCF into LCM is equal to the product of the 2 numbers. LCM into HCF is the product of 2 numbers. So if I multiply the HCF and LCM, that should be equal to the product of these 2 numbers. If I am getting these 2 equal, then I can say what I have done is correct. So HCF into LCM, 13 multiplied by 182, and RHS is the product of 26 into 91. Both of them should be exactly equal. So when I multiply these two, what are you going to get? You are going to get 2366 in both cases. So if you're getting a different answer in either of the two cases, then that means either you have taken HCF LCM wrong or you have multiplied wrong. So this is the method. I hope this is clear to you how to find out HCF and LCM of the numbers. So let me explain to you one more. 510 and 92. I'm going to get the factors of 510, 2, 5, 3, 17. And 92 is 2 square into 23. Okay. So if I'm doing the second part, 510 and 92 factors, I hope it's clear how to find out. It's a simple prime factorization, 2, 5, 3, 17. The order doesn't matter. You can write it in any form. And 92 is 2 into 2 into 23. That is 2 square into 23. Okay, 92 when I got the factors. Okay, this factorization, 2 goes 46, 2 goes 23. So this is 23 1. So 2 into 2 into 23, I'm going to write as 2 square into 23. So this is how we get. Now, what is HCF? HCF is what is common. So, in fact, to make it simpler, in the first step, I can show this, that I am writing this as 2 into 2 into 23. And then in the next step, I can show 2 square into 23. Now, what is common here? 2. So that is my HCF. So HCF is 2. So there can be more than one number common, then both those numbers will be HCF. You'll have to multiply that. Suppose there was a 5 here and 2 is also common, 5 is also common. So 2 and 5 both are common. So HCF would have been 10. Right now only 2 is common. So HCF is 2. Now what will be the LCM? As I told you, LCM is all the numbers without repetition in the highest power. So what are we going to do? We are going to take 5. We are going to take 3. We are going to take 17. We are going to take 23, all the numbers, no repetition. Okay, all these are different numbers. But here we are having 2 and here we are having 2 square. In the LCM, please remember, take the number without repetition, but in the highest power. So what is the power of 2 here? The power of 2 here is 1. And what is the power of 2 here? 2. So what is the higher power? The higher power is 2. So we are going to take the higher power. So that's going to be 2 square. So please remember in LCM to take the higher power, not the lower power. Okay, if you are having, let's say 3 square and 3 to the power 5, you are going to take 3 to the power 5, not 3 square. So LCM is, you can make a note of this, all numbers, okay, all numbers without repetition, no repetition of numbers allowed, in highest powers. In highest powers. So that means if you are having a 2 and a 2 square, you are not going to write 2 and 2 square both. You are going to write only 2 square. And now when you multiply this, you are going to get the LCM as 23460. Okay, 23460. And now the same procedure, you will have to verify that HCF into LCM is product of the two numbers. So HCF into LCM, HCF we have got 23460 is the LCM. Multiply this, we get 46920. And product of the numbers 510 into 92 also you will get the same. So that is how we find out the HCF and LCM is correct. Okay, the third one, 336 and 54, we can repeat. 2 to the power 4, 3, 7 and 54 is 2 into 3 cube. Okay, by prime factorization, what is common here? We have 2 and 3 common. So as I told you, there can be more than one number which is common. So 2 is in 3 is common, right? So when I say 336 is 2 into 2, okay, if I'm this 2 into 2 into 2, that's 4 times 2 into 3 into 7, and here I am getting 2 into 3 into 3 into 3. So when I'm taking common, there is a 2 common, and here there is a 3 common. Okay, there is a 2 common and there is a 3 common. So HCF is going to be 2 into 3, 6. So that is what I meant to say, that there could be more than one number which is common. If there are more than one number which is common, then you will have to take the two numbers and multiply, then you will get the HCF. So HCF is going to be 6. And LCM, as I told you, will be all the numbers without repetition in the highest power. So here we are having 2 to the power 4 and 2. So what will I take? I'll take 2 to the power 4. Here we have 3 and here we have 3 cube. So what will I take? I will take 3 cube. Here I am having 7. And I am going to multiply all this. Then I will get the LCM. So I have taken all the numbers, but I have not repeated anything. So I am taking 2 to the power 4 from here. I am taking 3 cube and 7 and I am multiplying. So what will happen? This will become 16 into 27 into 73024. And then the verification HCF into LCM is the product of numbers. Both sides you are getting 18,144. Okay, the same procedure now in question number 3. Find LCM and HCF of the following by applying prime factorization method. So in 3 numbers, there is no verification here, just you have to find the HCF and LCM. So 12 is 2 square into 3, 15 is 3 into 5, 21 is 3 into 7. What do you think is common in all this? 3 is common, so HCF is 3. And the same technique for LCM, write all the numbers without repetition in the highest power. So we are having 2 square, that I'm going to write. 3, I'm going to write, okay, all are 3, but I'm not going to repeat it. I will write it only once. 3 and 5 and 7, I'll multiply, I get 420. Okay, so that's the LCM. In the next one, 17, 23 and 29, nothing is common, but 1 is always common in all numbers. So don't write HCF as 0, HCF is 1. Okay, HCF is 1 because every number will have 1 as a factor. And what will be the LCM? LCM will be the product of these 3 numbers, 11, 3, 3, 9. Okay, same with this HCF 8, 9 and 25. This is 2 cube, 3 square, 5 square. Nothing is common, only 1 will be common. And what is the LCM? LCM will be the product of that is coming 1800. Okay, so as I told you that formula was important. Now this can be used here given that the HCF of 2 numbers is 9. Okay, 9 is the HCF and LCM you have to find out for the numbers 306 into 657. So what is the formula that I'm going to apply? I'm going to apply this formula. HCF into LCM is equal to the product of the numbers. First number multiplied by second number. So what is the LCM? LCM will be the product of the numbers divided by HCF. Right? LCM will be product of the numbers divided by HCF. So product of the numbers 306 into 657 divided by the HCF. So here HCF is already given to us as 9. So I'm going to do this. Now it is better that you cancel. Don't multiply and then divide. You can cancel either this or this by 9. So if I'm cancelling by 9, 3 is 27, 36. So this is going to be 4. So 34. Right? 9 3 is 27. Then 36 will come. Then 9. I could have also cancelled this. It's your wish. You can cancel one of them. So then multiply these two. You are going to get 2 2 3 3 8. Moving on to question 5. Check whether 6 to the power n can end with the digit 0 for any natural number. Now see, when does a digit end with 0? When does a digit end with 0? If you look at 10, 20, 40, 500, what is the common thing that you observe? They are all multiples of 10. Okay, only multiples of 10 ends with 0, compulsorily. You can say that multiples of 5 will end with 0 also, but not all multiples of 5, because 5 can end with 5 or 0. But when you talk about multiples of 10, you are 100% sure that it is going to end with 0. So all multiples of 10 are going to end with 0. That means the factors have to be 5 and 2 compulsorily. You need to have factors of what? 5 and 2. So question here is, can 6 to the power n end with the digit 0? Now, if you look at the factors of 6, what is the factors of 6? 6 can be written as 2 into 3 to the power n. So, as I said, that 6 to the power n can end with 0 only if it's a multiple of 10. And if it's a multiple of 10, it needs to have factors of 2 and 5. But here, when you look at the prime factors of 6, it is made up of 2 and 3. 5 is not present here. And therefore, what can we say? That it cannot end with 0. Okay. So what you need to write in these type of questions is that for any number to end with 0, the number has to be multiple of 10. So it needs to have factors of 2 and 5 compulsorily. But 6 has factors of 2 and 3. So it is not made up of 2 and 5, and therefore it cannot end with 0. So in the exam, they can change the question and say, can 14 to the power n end with 0 or not? So again, it is made up of 2 and 7. It cannot end with 0. Can 20 to the power n end with 0? The answer will be yes, because this is 2 into 2 into 5. It is made up of 2's and 5's. So it is important that you should have factors of 2 and 5. Then only it will end with 0. Otherwise, if you are not having 2 and 5, it will never end with 0. Okay. So that's the technique by which we can find out whether number will end with 0 when the power is n. N means any, 1, 2, 3, 4, infinite. Okay. Moving on to the next question. Explain why 7 into 11 into 13 plus 13 is a composite number. Now, what are composite numbers? Composite numbers are numbers which have more than 2 factors. Okay, more than 2 factors. If you are having more than 2 factors, then I can say it is a composite number. So look at the question here. 7 into 11 into 13 plus 13 has to be proved is composite. So if I want to solve, I will take 13 common. So what is left here? 7 into 11 plus 13 goes once. So this is going to be 13. This is going to be 77 plus 1. So this is 13 into 78. And if I look at the factors of 78, I am going to get 2 goes 39 times, 3 goes 13 times, 13 goes once. So how many factors are we going to get? 13 into 2 into 3 into 13 into 1. So 1, 2, 3, 4, 5, we have plenty of factors. So what is the conclusion? The conclusion is that it is a composite number. If this had only 2 factors, 1 and itself, then it would have been prime. Okay, so this is how we do this. I can help you to solve the second part also. 7 into 6 into 5 into 4 into 3 into 2 into 1 plus, what was that? Plus 5. We need to prove that this is a composite number. So take 5 common. So 7, 6, 4, 3, 2. Okay, plus 5 goes how many times in 5? 1. So this is going to be plus 1. So I'm going to multiply this 42 into, oh, these are 12, 12 is 24 plus 1. Okay, I'm multiplying this. I have not taken 5 because 5 is taken out. Okay, so now I'm going to multiply this 42 into 24. This is 48. 4 4 is 16, 6, 1, 9, so 8. So I'm going to get 1008 plus 1. So this is going to be 5 into 1009, and 1 is obviously a factor. So how many factors I'm getting? I'm getting 3 factors here, 5 into 1009 into 1. Therefore, this cannot be a prime number. This is also a composite number. So if I want to prove that any question or any combination of a series is composite, all you need to do is show that it has got more than 2 factors. Right. Then we go to the last question of that exercise. There is a circular path. Okay, there is a circular path of around a sports field. Sonia takes 18 minutes and Ravi takes 12 minutes for the same. After how many minutes will they meet again at the starting point? Okay, after how many? So what is happening? There is a circular path. It's a race, and one person is taking, 18 minutes. The other is taking 12 minutes. So I can consider this case as a circle. The first person is taking 18 minutes. Second person is taking only 12 minutes. Why is there a difference in timing? Because obviously the speeds are different. They're starting at the same time. Now, after how many minutes will they meet at the starting point? Now, they are moving at different speeds. So this person who is traveling very fast, because he's taking only 12 minutes, he will overtake this person at some point of time. So when will that happen? That we have to find out. So we need to find out the least common multiple, that is the LCM. When will they meet? After how many minutes? Okay. So what will I do? I will take out the factors of 18, that is 2 into 3 square. And I will take out the factors of 12, that is 2 square into 3. And now what will be the LCM? LCM we just now discussed. LCM is the product of the numbers without repeating in the highest power. So 2 and 2 square is there, so I'm going to take 2 square. 3 square and 3 is there, so I'm going to take 3 square. So this is going to be 4 multiplied by 9. So what will be the LCM? LCM is going to be 36. So that's your exercise 1.2. I hope you're going to revise this, and the concept should be clear. So you need to practice all these questions, and then you will be able to do these very comfortably.